You know that old saying, two heads are better than one? Well, it turns out that might be true for artificial intelligence too. Today, we're diving into a really cool new way to teach AI, not with a single all-knowing genius, but with something more like a collaborative study group.
And that question really gets to the heart of the problem here. Even our most powerful AI models can get stuck in a rut, right? They get great at what they already know, but they really struggle to make those big creative leaps. So how do you teach a machine to have a genuine aha moment?
All right, here's our game plan. We're going to start with why even the smartest AIs hit a wall. Then we'll look at the two classic but kind of flawed teaching methods. After that, we'll introduce this new classroom idea, learn its rules, check out its grades, and finally talk about why this could make AI smarter and way, way faster.
So to really get what's so special about this new approach, we first have to understand the problem. The way we usually train AI with something called reinforcement learning is kind of like letting it teach itself through trial and error. But that self-study approach has a pretty big catch. And that catch creates something you can think of as a knowledge bubble. The researchers behind this paper say that AIs trained this way often get confined within their own knowledge boundaries. Basically, they get incredibly good at solving problems the way they already know how, but they find it almost impossible to discover totally new strategies that are outside that bubble.
So researchers have tried a couple of main ways to pop this knowledge bubble. You can either let the AI just keep exploring on its own, hoping for a breakthrough, or you can bring in a single super intelligent genius model to teach it. But as we're about to see, both of these ideas have some serious drawbacks.
And this slide just lays out the dilemma perfectly. On the one hand, with self-exploration, the AI is pretty much stuck. It's like trying to learn calculus when all you've got is an algebra textbook. But on the other hand, if you learn from just one super teacher, you run the risk of just becoming a clone, locked into one way of thinking, which can totally kill your creativity.
And this is where the big idea comes in. Instead of learning alone, or from a single tutor, what if there was another way? Researchers came up with a totally new kind of classroom, a method that actually gives you the best of both worlds. The solution is a framework called AMPO. Now, you can think of it as a study group for AIs. That's the key. It uses the collective brain power of multiple teacher models. But here's the real magic. The group only steps in to help when the student AI has tried and failed to find any correct solutions on its own. It's help, but only when it's absolutely needed. This AI study group doesn't just work by accident. It's incredibly effective because it follows two really simple but super powerful rules. Okay, so rule number one is guidance on demand. Help isn't constant. It's a lifeline that only gets thrown when the AI is completely stumped. This is huge because it preserves the value of self-discovery. Then there's rule number two, comprehension-based selection, which is just brilliant. When help is offered, the student AI gets to choose the explanation it thinks it's most likely to understand. That way, the lesson actually sticks.
That all sounds great in theory, right? But does it actually work? Well, let's take a look at the AMPO model's grades after it joined this new kind of study group. And yeah, the results are pretty darn impressive. First up, math reasoning. The AMPO model, the one with the study group, outperformed the self-study model by a full 4.3%. That's a really solid improvement right out of the gate.
But this is where things get really exciting. When they tested it on problems and concepts it had never seen before, out of distribution tasks, the AMPO model showed a massive 12.2% jump in performance. This proves it's not just memorizing, it's really learning how to reason in a much more flexible way.
And the benefits go beyond just getting the right answer. AMPO also boosted what's called past K performance. In simple terms, that's a measure of the AI's ability to generate multiple different correct solutions to the same problem. So basically, the AMPO model learned to find more ways to be right, avoiding that trap of getting locked into just one way of thinking.
Now this table right here might be the most important result of all. AMPO achieved performance that was just as good as a model trained by a single, much more powerful superteacher. But look at the data used. AMPO did it with over 5 times less data. That's an incredible leap in data efficiency, which is a total game changer for the cost and scale of training these models.
And as a final little bonus, the AMPO model also learned to be more concise. The research found it consistently produced shorter, more streamlined paths to get to the correct answer. So it's not just smarter, it's more efficient too.
So what's the big picture here? Why does a new training method matter to all of us?
Well, this isn't just a small improvement. It really points toward a new way of thinking about how we build artificial intelligence.
This quote from the researchers just nails it. For AI, just like for people, learning isn't about finding the one perfect teacher. It's about drawing from a whole bunch of different perspectives to build a richer, more flexible, and just plain tougher understanding of the world.
So, what you should really take away from all this is that AMPO offers a fundamentally new recipe for building AI. It's about engineering curiosity, preventing models from getting stuck in one mindset, and teaching them how to apply what they know to problems they've never seen before, all while being incredibly efficient. This isn't just an upgrade, it's a new path to smarter, more versatile AI.
And that leaves us with a fascinating final thought to chew on. This research proves that for machines, collaborative learning from a group of peers is more effective than learning from a single isolated genius. So if that's the key to unlocking the next level of artificial intelligence, what does it tell us about the future of our own?